Okay, hello everyone. So today I will be talking about anti-realism and black holes, and I'm trying to defend an anti-realist account of black holes. But it might sound a bit strange for those who know anti-realism, because the very person who has coined this term anti-realism, Ian Hacking, was an anti-realist about black holes and about all extragalactic entities, including gravitational lenses. And recently, Simon Alden has argued that it's somehow impossible to argue for the realism of black holes on the basis of anti-realism, and not only based on Ian Hacking's account, but also based on the work of Nancy Cartwright and Anjan Chakraborty. We cannot be anti-realist about black holes. On this basis, you cannot be a realist with respect to black holes, and likewise, if you want to be a realist about black holes, you cannot be an anti-realist. And the main reason is that for Ian Hacking, manipulation is of utmost importance in his argument, experimental argument for the reality of entities. You should be able to manipulate one object to see and to investigate another phenomena to be realist about that object. And this is not possible because we cannot manipulate black holes. And in other anti-realist accounts, it seems that because they, in the case of black holes, theories and models are most important in inferring the existence of black holes. And for anti-realists, it seems that these aspects are problematic. The relatedness of our inferences are problematic. So it's challenging to be realist about black holes on the basis of anti-realism. But on the other hand, there seems to be a widespread scientific consensus about the existence of black holes. So there is a dilemma here in front of anti-realists. Either they should respect this widespread scientific consensus about the existence of black holes and reject anti-realism, or they could remain anti-realist and be anti-realist about black holes. So there seems to be a dilemma in front of them. Either they should accept this consensus among scientists, or they bite the bullet by suspending belief in black holes. And I would try to resolve this dilemma. And so my primary aim in this talk is to resolve this dilemma by showing that both horns of this dilemma are problematic, and so we can have an anti-realist account of black holes, and the consensus of scientists doesn't reflect out and out theory realism about black holes. So that's my primary aim in this talk. And first of all, I try to build on new accounts of anti-realism. So as far as I see the literature, there are many accounts of, or several accounts of anti-realism in the literature, and you can find some more recent accounts that have advanced anti-realism in one way or another way, by studying new cases or by modifying their criterion for reality or for addressing objections. So some of these accounts are here, for example, in Matthias Egg or in Shannon Waller, in Marcus Aronen. And I have tried in one of my publications to integrate the insights of these different accounts with each other. So anti-realists are not just Ian Hacking and Nancy Cartwright and Ronald Geary. There are some more recent accounts. And for them, I would say that three conditions are really important and central. And if an entity can pass, or a hypothesis that we have about an entity can pass these conditions, we can be realist about that entity. One of them is empirical evidence. We should have robust empirical evidence. And there should be a causal relation, well-defined causal relation that can help us to infer the existence of an entity based on empirical evidence. And at the end, the criterion of non-redundancy, the thing that we infer should be non-redundant in the sense that no viable alternative should be seriously conceived in the literature. So there is a causal relation here from the effect to the cause, and empirical evidence is the effect. That effect should be robust and supported by robust empirical evidence. And manipulability here is more important than manipulation itself. So manipulability of an entity, as I will explain further, help to have a well-defined notion of what it means to manipulate something, and to have a well-defined notion of causal relation between the effect and the cause. So we will be discussing these three criteria in this talk. But something that I would like to highlight is that in this new account of anti-realism, first of all, there is no in principle superiority of manipulation over observation. It seems that in Ian Hacking's account, there is this superiority. Manipulation is more important than observation, mere observation. So experiment is preferable to observation. This superiority is not important. So it depends on the cases. In some cases, observation might be epistemically preferable to manipulation, and in some cases, manipulation to observation. So this is, I think, something that is more or less common in this new account of anti-realism. The different people who defend this anti-realism, I think they agree with this statement. And Woodward's account of causation is also respected in this new literature. And the account is non-human-centered. We should not, as humans, it's not required that we as humans manipulate in something to be sure that something is real. So natural experiments or hypothetical interventions or simulations or other kind of manipulations in a very broad sense, kind of interventions in a very broad sense, all can be considered as ways to define the manipulability and causal relation between the cause and effect. So here we can consider kind of cosmic laboratory in which we have natural experiments, and then we can observe the interaction between different objects. And yeah, as I said, manipulability is more important than manipulation because it can provide us with the definition on how we define the relation between the cause and the effect. So now I try to discuss those three criteria. I start with manipulability. So for manipulability, it's important to have a well-defined notion of what it means to manipulate something. And so that something should be well-defined, first of all. And we have different, so we should have a well-defined notion of what is a black hole. There are different definitions in the literature. I will come back to these many definitions of black holes because there are many definitions in different subfields of physics. But I could mention, for example, definition based on event horizon, apparent horizon, and the astrophysical definition. The event horizon is defined as the boundary of the causal past of future null infinity, which is a mathematical construct. And it doesn't have a well-defined location within space-time, and because of that, manipulatability of such a construct doesn't sound straightforward. But a notion closer to observational purposes is apparent horizon, which is the outermost surface of which light rays neither expand outward nor collapse inward. So here we have at least a location. The location can be, in principle, determined locally, and a notion even closer to observational purposes is simply an object with certain properties like mass, spin, and charge. This object is compact with high energy, but this is a no escape region, so nothing even light can escape from within a black hole. So this notion is the closest one to observational purposes and to be considered as something manipulable as well. And something that is important is in what sense black holes are empirically accessible because from within them no light can escape, so that part is invisible. But because they have causal impact on the environment and that environment on other environment, and then we can receive the signals through our receptors. In this sense, they are empirically accessible. So I do not like to use this distinction between observable and unobservable, which is quite problematic. But it's safe to say that black holes in this sense is empirically accessible. Okay, now about manipulability. So now we have a rough definition idea of what is the notion of a black hole and in what sense they are manipulable. So there are different ways to see how they are manipulable. One of them is hypothetical manipulation. And as you see in this quotation, we can extract energy from a black hole and use it in manipulating other objects. So at least hypothetically, it's possible to manipulate black holes in a Hawkingian sense. And we can use that energy to, for the purpose of, for example, gravity assist maneuvers. We use this kind of maneuvers in speeding up spacecrafts. So if black holes were close enough to us, we could use them as some object to speed up other objects. In this sense, they are hypothetically manipulable. And natural experiments. So the definition of natural experiments are processes in nature that exhibit the feature of an intervention, but are not the result of human action. So there are experiments, but we as humans do not design the experiment. And we can see that in, for example, accretion, mergers, and comparison of different black holes, we can find sort of manipulability. One of them that I think it's more clear is the mergers. So when two black holes merge with each other, they produce gravitational waves, and these waves are detected by our detectors. And fortunately, the signal received contain information about both the time before merging and after merging. So both about the progenitors and the remnant. And in this case, we can construct this, process of merging because we have the information about both sides. So about the dynamism, we can reconstruct the kind of dynamism that happens there. So it seems that two black holes merge, and so this is an experiment. We have information about the time before and time after merging. This is kind of natural experiment, and in this sense, they are manipulable, even if we as humans do not manipulate them. And analog experiments are also important here, I think. So we can have material models of black holes, like sonic holes in fluids or optical analogs, and then manipulate in those models. And if there is a good argument that structurally these models are the same as black holes, then or similar in important aspects, then we can infer some features about black holes based on the manipulation that we had on the model. But there are limitations because this analogy doesn't work in some cases, there are some controversy about this, to what extent we can use this this argument based of analogy. But apart from that, it's another option beside natural experiment and hypothetical manipulation to understand what it means to manipulate black holes. So one purpose that we have here is to understand what it means to manipulate them, not to manipulate them in practice. And in addition to them, I can also mention simulation. In simulation, you change the parameters and see a change in the outcome. And so all of them can provide a very well-defined notion of what it means to manipulate black holes, to merge them with each other, to change their mass, to change properties. So in this sense, we have a well-defined notion of what it means to change black holes and see the impact in the results or in the effect. But this is just one criterion. The other one is evidence that we have for black holes. And here the notion of robustness is important. So in the case of, for example, the Event Horizon Telescope detection of black holes, robustness is a key, and these two quotations are from a white paper published by one of the working groups of Event Horizon Telescope collaboration. And so you can find that robustness is important for them, and they have a very conservative strategy to use different teams involved, and then a variety of different algorithms to analyze data and to use different parameter values. And this paper by Pavlovsky and Elder elaborate on these aspects. Yeah, but this is just one case, the Event Horizon Telescope detection of black holes. So that, assume that you know that in this case that there are a variety of different infrastructures all around the world, and all of them artificially make a very big telescope, like the Earth becomes like a telescope, and then we can see or observe black holes through this very big artificial telescope. And in this case, the notion of robustness is important. So they try to have robust evidence and be conservative in corroborating or confirming the results based on different ways, a variety of different things, algorithms, and parameter values. But this is just one way of detecting. In Event Horizon, radio waves are detected, but we also have other ways of detecting black holes. For example, in LIGO, Virgo and Kagra collaboration, gravitational waves are detected, or X-ray observation of stellar mass black holes, or they are among the most early ways of detecting black holes. And there are a variety of different messengers. These are called messengers, and this astronomy is called multi-messenger astronomy. There are different ways, and it's more similar to kind of argument that anti-realists have. And in hacking work, in contract work, and in error, and you can find it that if you have different ways and mechanisms of detecting something, it makes sure that that something should exist. Or, for example, Hacking's example is microscopic contract is about the existence of atoms, different models that you have to infer atoms based on different empirical evidence, and then models that you use make sure that atoms exist, even if you do not adopt a realist attitude toward these models, but they are good enough to be used to infer something that is common in all of them. And in Erronen, this is developed further, and it's called robust anti-realism. So we have that structure of argument can be applied in the case of black holes as well. But the other and the third criterion is non-redundancy. We might have robust evidence, but that evidence might be accounted for by different hypotheses. So robustness doesn't sound to be sufficient. So we might have very different ways of detecting an object, but then another alternative object might account for all of the evidence. So here, a different line of inquiry is needed, that we should see the scientific community and how they treat alternatives. But something that is important is that skeptical scenarios are not taken seriously, at least in the philosophy of science literature. So the alternatives should be scientific, not very skeptical, crazy ideas. And here, eliminative reasoning is central, and I would say it's exactly the sort of argument or reasoning that that anti-realists have in mind when they they speak about this notion of non-redundancy. And so you can find that elementary reasoning was important, for example, for one alternative for black holes were at some point neutron stars, but then no compelling evidence showed that it cannot be a viable, serious alternative. And now I think there is a kind of meta-level evidence for defending that that black hole hypothesis is not non-redundant. Yeah, is non-redundant. Because you know, this is kind of, as I said, it's a different kind of inquiry that we could have. It's not just looking at empirical evidence. We should look at the society, to the scientific community, to see if they have conceived of enough alternatives, and the community is big enough. They have conceived of alternative for like decades, and they have many different perspectives and so on and so forth. And when you see that after several decades they have thought about many alternatives and still black holes are there, it seems that this notion of non-redundancy in this condition is also fulfilled. But there could be this objection that in elementary reasoning, scientists usually rely on theories and models, and all of them, for example, are defined or interpreted on the basis of GR and models or simulations. And it is assumed that entity-realists, in this objection, it's assumed that entity-realists are sort of anti-theory or anti-models. They don't like theories or models, but I think we should be precise here about the accounts that they have. So, for example, Cartwright has discussed models extensively, and or for hacking, the issues are something else. So, for example, for Cartwright, relying on one particular model is problematic. But when we use, as I said, in the case of the existence of atoms, when we use different models and we do not rely just on one of them, so the use of models are not problematic. Or for hacking, so usually in the literature, this more recent literature on black hole and more generally on astrophysics, hacking is used as a foil. But when you read his text more precisely, you find that he's quite optimistic about observation. For example, he accommodates in chapter 10 of his 1983 book, he accommodates Bacon's claim that instruments can evoke invisible events or entities, thereby making them manifest, or he endorses Chaper's notion of observation, direct observation of sun's interior through collecting neutrinos. But the worry that he has is about vicious circularity, and so in these quotations I try to show them. So he adds up these two criteria are criterion suggested by Chaper, that X is directly observed if the information received by the receptor and detector, and the information is not interfered with, it's not interrupted. But hacking adds one further condition, that there should not be any vicious circularity. So if the observation is theory-laden, is interpreted by a theory, and that theory should not assume the entity. So, or it should not be dependent on another theory, and then this theory dependent on that observation. Something like vicious circularity should not happen here. Yeah, this unity of science is important here. So if our observation relies on models or certain models or theoretical construct, these theoretical constructs should not then assume then the observation should not convert these models. They should convert another theoretical assumption or something like that. There shouldn't be this circularity, and because of this unity of science, we can avoid vicious circularity. So for me, as I see, yeah, massively and theory latedness of observational astrophysics is not the main problem. The main problem is that in massive theory latedness, you might find problematic circularity, and that's the main problem. So for sure, our inability to manipulate objects is central for Ian Hacking's anti-realism against black holes. That's for sure. But in his argument, as I constructed here, something else is also important. That in that case, we don't have observation. For example, at the time of the publication of the paper in 1989, we didn't have observation of gravitational lenses or black holes because of this vicious circularity. This is also part of the argument that is usually dismissed. So, what about this vicious circularity, this sort of theory latedness and circularity at our present time? So, another paper by Dobrowski and Elder addresses this issue, and it's published just recently, and shows that still the problem is important. So this is interesting, but they elaborate on different kinds of circularity and problematic situations, and they argue that there are strategies. There are strategies to mitigate these kind of circularities, and they elaborate on that. For example, weakening explicit generic effects parametrization, and they are strategies that are used in the detection of black holes in the LIGO Virgo and also the Event Horizon Telescope observation. So in these two cases, which are very recent observations of black holes, these kind of strategies have been used. Okay, and relaxing even GR assumptions are part of these strategies. So I do not explain them here, but I'm quite convinced that these strategies work well. So we can have observation in the case of black holes, even in according to Hacking's standards. And then an entity-realist account of black holes is supportable. But one might say that no, still those strategies are problematic. And in this case, so the kind of argumentative strategy that I have is that there wouldn't be any consensus among scientists anymore, or the consensus is not founded or is not reasonable because it's based on problematic circularity if those strategies don't work. And in this sense, the ER dilemma wouldn't be an objection anymore, because of that circularity, then an anti-realist account would be preferable, and so the Hacking's initial argument was valid. But anyway, this is just for the purpose of dialectic. I think that those strategies work well, and we can have an entity-realist account of black holes. But why entity realism and not a full-blown or out-and-out realism of black holes? Simply because we have a variety of different theoretical and mathematical notions of black holes. And this paper by Eric Curiel is, I think, very important. And he argues that in different subfields of physics, in astrophysics, in classical relativity, mathematical relativity, semi-classical gravity, thermodynamical, and quantum gravity, we have a variety of different theoretical image of or notions of black holes. So we cannot be, simply because of this polarity, and all of them work in their subfields very well. So it doesn't show that they are there is any problem in this plurality. We need that plurality, and this is quite consistent with the main idea of anti-realism, that the realist attitude should be toward the existence of certain properties. For example, mass, in this case of black holes, is quite safe to be realist about black holes and certain properties of them that are detected through instruments and But then about a very full-blown theoretical image of black holes, we simply cannot be realist. There are many different images, and some of them are exotic, defined in more than three-dimensional space-time. So anti-realism, I would say, that can provide a reconstruction of current scientific knowledge of black holes. Construction in the sense that Stanford has in one of his papers. So it can reconstruct what is going on in a very naturalistic way. It's a combination of realism and non-realism still. It's a combination of optimism and sort of, I would not say pessimism or I don't know really the word I have written them, but about theoretical part, and adopting a realist account about the theoretical part. It sounds not very optimistic project to have a project to be realist about the theoretical part because of this pluralism. And that's, yeah, it's, thank you very much.